AP Stats, Quideo 5. So my basic question, in which of the following situations can you safely use the methods of inference for a population proportion for a significance test? Explain your answer. So part A, you toss a coin 10 times in order to test the hypothesis, ho, p, so probability equals 0.5, that the coin is balanced. My response was, this population proportion cannot be used for a significance test because the success and failure / probability rate both equal to 5, which is less than 10, and the success equation will be my n, which is my number of my population, and my p is my probability sub 0 equals to 10, multiply that by 0.5 sub 0 equals 5, and my failure will be n minus, in quotation 1 minus p sub 0, which would be 10 quotation 1 minus 0.5, which again will give me 0.5. Part B, a college president says 99% of the alumni support my firing of Coach Boggs. You contact a simple random sample of 200 of the college's 15,000 living alumni to test the hypothesis. Your HO, or your null hypothesis, probability is 0.99. So my response was, the population cannot be used for a significance test as well because the expected number of failures is less than 10 when using the simple random sample of 200 students. My equation was in quotation 1 minus my p sub 0, and when I plug in my numbers, 200 quotation 1 minus my 0.99 will give me 2, which is again is less than 10%, or 10, sorry. Part C, do a majority of 250 students in a statistics course agree that knowing statistics will help them in future careers? You interview a simple random sample of 200 students to test the whole, and your probability is 0.5. So my response was that this population proportion can be used for a significance test because we have a simple random sample. The population is larger than 10 times the sample given, and the equation, my n, my p sub 0, so and my equation will be n quotation 1 minus p sub 0, so my 20 quotation 1 minus 0.5 will equal 10. Time for my advanced question. For each of the following situations, state whether a type 1, a type 2, or neither error has been made. Explain briefly. So part A bank wants to see if the enrollment on their website is about 30% based on a small sample of customers. It tests the whole probability of 0.3 versus alternative hypothesis, which is your p will be larger than your 0.3, and rejects the null hypothesis. Later, the bank finds out that actually 28% of all customers enrolled. My response was, this situation will be a type 1 error due to the alpha being larger than the hypothesis, along with them rejecting the true null hypothesis. Part B, a student tests 100 students to determine whether other students on her campus prefer Coke or Pepsi and finds no evidence that preference for a Coke is not 0.5. Later, a marketing company tests all students on campus and finds no difference. And my response for that one, the situation will be neither error has been made since the alpha value isn't rejected or failed. Part C, a pharmaceutical company tests whether a drug lifts the headache relief rate from the 25% achieved by the placebo. The test fails to reject the null hypothesis because the p-value is 0.465. Further, testing shows that the drug actually relieves headaches in 38% of people. And my response was, this situation is a type 2 error because the null hypothesis was false, causing us to fail to reject the whole. Also, the true relief rate was greater than the 0.25%. Time for my AP question. Researchers want to determine whether drivers are significantly more distracted while driving when using a cell phone than one talking to a passenger in the car. In a study involving 48 people, 24 people were randomly assigned to drive in a driving simulator while using a cell phone. The remaining 24 were assigned to drive in the driving simulator while talking to a passenger in the simulator. Part of the driving simulation for both groups involved asking drivers to exit the freeway at a particular exit. In the study, 7 of the 24 cell phone users missed the exit, while 2 of the 24 talking to a passenger missed the exit. So part A of my AP question. Would this study be classified as an experiment or an observational study? Provide an explanation to support your answer. So for my response, I said this study would be classified as an experiment because out of the 48 people, all were randomly assigned to a different task, whether cell phone group or having a passenger group. If it was only observational, there wouldn't have been no environmental changes or changes dealing with the subjects with other interferences, but putting them in a simulation or giving them cell phones distracted them, causing outside or environmental changes. Part B, state the null and alternative hypothesis of interest to the researchers. So my response was my null hypothesis was P cell equals P pass, and I break that down. So this is all the people who missed the exit while talking on their phones, and your P pass is the number of passengers in the car. This is also the true null hypothesis. But to continue on, my is my P cell equals my P pass, and my alternative hypothesis is my P cell is greater than my P pass. For part C, one test of significance that you might consider using to answer the researcher's question is a two-way sample z-test. State the conditions required for this test to be appropriate, then comment on whether each condition is met. So, my two sample z-test requirements. First, it's a random sample. It's a simple random sample was stated. Each treatment was assigned randomly, and my N cell P cell equals 7 is not equal to 10. So to break that down, 7 people out of the 24 people using cell phones who missed the exit is less than 10. And for my alternative, so the 17 people that made the exit is larger than the 10 required. And for the people that had a passenger in the car, 2 out of 24 missed it exit, so that which is less than 10. And for the alternative, 22 people made the exit out of 10, which is larger. So the conditions are not satisfied. So it needs to be a larger sample size. Also, we can assume that each test was independent from one another because the two groups were randomly assigned, and both passengers while driving and talking on the phone while driving were both larger than 10%. Were larger than the 10% rule. Also, my p hat equals 7 plus 2 divided by 48 equals 0.1875. To break down even more, 7 is the number of people who missed the exit due to talking on the phone, and 2 is the number of people who missed the exit due to passengers. So 24 which was given in each sample, which was which was evenly distributed out of the 48 people. And so this is my null hypothesis, my 0.1875, and we're trying this test and see if it's larger than 10, which is not, it's 4.5, so that condition is not met. And this is my alternative hypothesis, so my remaining value of 0.8125, and seeing if that is larger than 10 as well, which is 19.5, which means that condition will be met.